classroom friends. In today's class, we are going to learn about the diagrammatic representation of geographical features. First, let me introduce the topic for you. In order to know about the different features of our planet Earth, the diagrammatic representation is needed. A diagrammatic representation is the depiction of the different features of our planet Earth with different diagrammatic symbols. Now we can learn about the diagrammatic representation of rivers and mountains. Firstly, we can learn about rivers. So most of you know that river is formed in the top of a mountain. They are formed when glaciers melt and also when rain falls on the mountains. Now let me explain it clearly for you. A glacier is nothing than a group of ice that are formed like a mountain. So when these glaciers melt, the water flows as a river. This is one way to start the beginning of the river. Next one is rain-fed rivers. So rain-fed is nothing than, just imagine this is a mountain. So when rain falls on it, the water flows down here and it forms a river. So there are snow-fed and rain-fed rivers. So this is how the life of a river begins. Okay. A river has three courses in its life. They are upper course, the youthful stage of the river; middle course, the mature stage of the river; lower course, the old age of the river. Okay, in the upper course, the source is the mountains or hills, and the middle course, transportation and deposition takes place. In the lower course, only deposition takes place. Now we can learn clearly about the upper course, middle course, and lower course. Upper course. The first stage of the river at the top of the mountain is the upper course. This upper course has lot of energy and force, so when it flows down, it erodes all the rocks and the boulders and hard surfaces. So this is the main thing about the upper course. And in the upper course only it's used to take hydroelectricity. Now let me explain this for you. Water is channeled through the channels. Channel is nothing then, just imagine this is a jam. So in this part there's a small type of channel, right? This is called the channel. So when water flows through this area, there are turbines. So when these turbines move, the generators move to take electricity from this water. So this generators are nothing than machines that take electricity from water. So this method is called the hydroelectricity. So do you know why hydroelectricity is only taken in upper course? As there's lots of force and energy, there will be lots of electricity in it. That's why we check there's hydroelectricity power stations in the upper course. In the middle course, it's nothing in the mature stage of the river. Okay. This is the second stage of the river, but it loses all its energy. Do you know why? In the upper course, it erodes, right? So in the middle course, it carries all that rocks, boulders, and it carries everything into plains. So imagine this is a plain. So a river is flowing down. Will it lose its energy? It will. So then losing its energy, it also deposits fine silt and alluvium. Okay. So these alluvium are nothing than fertile soil. So it deposits all these in this fertile plains. So when it deposits, it forms meanders or oxbow lakes. Many small rivers known as tributaries meet the main river at this stage. Imagine that this is the main river. So the tributaries that are coming from here to meet the main river, or they are known as tributaries. Distributaries are nothing than from the main river they are coming out. Small branches of river that is coming out from the main river is known as distribution. Okay, so distributaries are nothing than small rivers or streams that are coming out from a main river. Tributaries are small streams and rivers that are meeting the main river. Understood? Yeah. So this is the main thing in the middle course. So the middle course, they won't take hydroelectricity. electricity, but because it doesn't have any force and energy. Next is lower course. Then the middle course itself there's no energy, means just imagine the lower course. In the lower course, it deposits more fertile silt and alluvium, forming a very fertile delta. So this is a delta. No? This is the delta. Okay, let me tell this interesting fact for you. Okay, the origin of the river, the place where it originates is called the source of the river. The place where the river meets the sea. So this is the sea. Here comes a river. Okay, just imagine like that. This is the sea and here comes a river. So this point is a point where the sea and also the river meets that. So this point is known as the mouth of the river. So the mouth of the river. Okay? Yeah. And now we can learn about the lower course. Okay. So this lower course have many distributaries. I told it there are small branches of rivers that come out from these main rivers. So this forms a large delta. So this is the main river and these are distributaries, and this part is known as the deposition, where it deposits all this fertile silt and alluvium in these areas. Okay? Okay. Now we can learn about this. It's nothing then. Because of the force, it makes V-shaped very steep valleys in the upper course. We learned that it has a lot of force so that it can form very steep V-shaped valley. Here, the middle course, it doesn't have much force, so that it just erodes a little bit. That's why here it's very deep. Here just a little bit of deepness. And the deposition of alluvium, it doesn't erode anything. Just deposits all the fine silt and alluvium, which is like the fertile soil. Okay? So the three stages of the river are upper course, middle course, and lower course. Okay. Now we can move to anticline and syncline. Before we learn about this, we can just learn about what is force. Okay. There are many changes in the earth. Okay. So the internal forces and external forces that are happening in the earth cause many folds and faults. Okay. The folds are formed in the condition of stress, temperature, and pressure. Okay, the fold is nothing then. This is a very flat area. Instead of being a flat area, it used to be like this. Like something else like not straight. That is known as a fold. But don't think it will be like this. It won't form like that. It will be like this due to certain temperature, stress and pressure. It forms very curved like surfaces. And this is how mountains form. We don't need to go to mountain topic. Now we can learn about the anticline and syncline. Okay. Now let's learn about what is stress. The area of the per unit, the stress of the pressure that's applied in an area of the per unit of a substance is known as a stress. The change in the form of rock. Imagine this is a rock. So instead of being like this, the shape will be like this, something irregular. So that is called as deformation. So when the stress everything squeezes and compresses the rocks, it's known as compression. When the stress just stretches the rocks, it's known as tension. Okay, now we learned about stress, then deformation, the compression and tension. So these four are the ones that torture the rocks and make them into folds. But don't confuse folds and faults. Faults are nothing than cracks in the earth's surface. Not in the earth's surface, the earth's crust. So in this part, there will be just a small crack. Instead of being like this, there will be a small cracks. So this is called as a fault. Okay, but we will be learning about that in block mountain. Now anticline and syncline. Okay, now we can learn about that. Anticline is a raised surface. Okay, I'll explain it with my hands. So Imagine that these are two tectonic plates and there are a lot of stress and many temperature changes. So what will happen? It changes into like this. So this part now, this is called as the crust of the anticline. This top is called as the crust of the anticline. Okay, and this downward part is known as syncline. Here it is written. This is the anticline. This is the syncline. Okay. Now folds are classified into how? Due to shape, size, and their tightness. Folds can be also classified through the layer which the surface of the earth is built. Now what do you mean? I think you can understand. It's nothing that if the upper parts of the earth is just binged and if the lower parts of the earth is binged, through this we can also classify the folds. Okay, so I told you like anticline or the top of the fold and syncline or the downward part of the fold. So this anticline, they were like arcs and they made in such a way that the arcs are above the surface land. So this is an anticline. The syncline is the earth's crust that it sinks up and it comes up. So, but don't think that syncline rests to a valley. It's not a valley. So in the mountain itself, if it's like that, means it's known as syncline. So these synclines have newer rocks at its core or center and older rocks at the other sides. In the anticline, the same only, but it has new rocks at the center but no older rocks. So this is the anticline and syncline. Basins. But no, there's not that much basins, but when you go to moon, you can see lots of basins. So these basins are the depression caused by the syncline. Okay, now let's learn about why this, these type of basins are only in moon. Because as many asteroids hit on the moon, some type of craters are forming. So these craters are filled with lava. So this is because of what? The compression and force of the asteroid that causes the craters. So this is what? This is the basin. Not only the moon, in some mountains too it's happening. Okay? So we learned about anticline and syncline. Okay, now we can learn about block mountains. Okay, now I told you like that fault is a crack in the earth's surface, right? So when this crack occurs and the tensional tectonic plates move and collide within each other, do you know what happens? Block mountains occurs. Okay, now let me ask you a question. What are the examples of the mountains that are formed by faults? Okay, I know some examples. They are Himalaya mountain in Asia, Rocky mountain in America, South America's Andes and Europe's Alps. So these are the mountains that are formed when two tectonic plates collide and they just crumble. Okay? And the anticline looks like a R, and how does the syncline look? Like drops. It's not a drought, it's a trough. Okay. So these block mountains are divided into two categories, lifted and sloped. Okay. Now, if a part of the Earth's crust falls between two parallel faults, a steep-sided mountain can be found. So this mountain is known as the lifted block mountain. The slope is the same but totally opposite. Here, when a part falls down and a steep shape just goes up, that is lifted, but in slope it's totally opposite, means the part of the Earth's crust, it just slopes down. And a block mountain can be found in rift valleys. So this type of block mountains are known as sloped mountains. So in Germany, block mountains are known as host. Rift mountains are known as rift mountain is known as sorry, I forgot it. Yeah. And some of the examples of block mountains. Okay, don't confuse fold mountains and block mountains. Or Vosges mountains in France, Black Forest mountains in Germany, and Vindhya mountain in India. So the India mountain that's located in India is a type of block mountains. you understood my teaching today. So we learned about nothing but the diagrammatic representation of the rivers and the mountains. So in mountains we learned how anticline and syncline occur and falls. Then we learned about block mountains, lifted and sloped. In rivers we learned about the stages of the river and delta. Okay friends, hope you understand my teaching today. Thank you friends. Bye. See you in the next class.